Hi. So far we've been able to draw objects, animate them on our screen, but we don't have real physics yet. In this video we're going to be working on adding a physics engine to our game so that we have some realistic movement. The physics engine we're going to be using in Collidium is called PhysicsJS. It's a physics engine written purely in JavaScript, and it suffices for the functions we need from the physics engine. But before we go and start using this physics engine to manipulate objects in our game, we need to be able to access PhysicsJS in a type-safe manner. So we're going to write facades to be able to do that. In Scala.js, one of the really great features is interoperability with JavaScript code. And since Scala is a statically typed language, in Scala.js you can actually define static types that represent types that are in a JavaScript library. So that's what we're going to be doing in this video. To create the static types for PhysicsJS, I'm going to be using their API reference. And one of the nice things they've done in this API docs is they actually provide names that could be used to understand how this library is built. I'm going to go over and switch over to IntelliJ, and I'm going to create a package in Scala called PhysicsJS. Now inside this PhysicsJS class, I'm going to create a Scala class. I'm going to call this Physics. This is actually going to be an object. The first type we're going to build for our facade for PhysicsJS is the top level namespace physics. Now this does two things. One, it contains all of PhysicsJS, and two, we can use physics as a function to create a new world. So here they're giving us an example of how you would use this method, physics. It takes a configuration and a function that, given the world, what do you want to do with it? We can actually omit both configuration and this world function, this function from world to how do you want to use it. And this method will instead just return us the world. And in JavaScript, the way this would look like is it would check if the configuration and the function are defined, and based on which ones are defined, then it'll return you the appropriate type. So I can go over and switch over to IntelliJ. The first thing when defining a facade in Scala.js is making all of the types that represent JavaScript objects extend js.object. And this is how you tell the Scala.js compiler that this is a facade for a type that exists in some other JavaScript code. Now another thing we have to do is tell where this Scala object is located within the Java code. And we know this is a top level object called physics. So we're going to do @JSName, which is an annotation that takes a string of where it's located. And this is going to be physics. Now we can define our method to create the world. We're going to do def apply, which doesn't take any parameters because that's the method we're going to need to use. And that's going to return us a world. And in Scala.js, when you have a method that is a facade for a JavaScript method, you implement it as js.native. And so this will go into the JavaScript code. Now, we haven't implemented the type for world yet, so let's do that. World isn't an object in this case because you can't directly call methods on the world. You have to get a world from some other object and then act on it. So world is going to be a trait. Trait world. And this is going to extend js.object as well, because when we use it, it's a JavaScript object. Now we can go over and switch over to the PhysicsJS docs, and we can take a look at world and what we can do with this. So when we have our world, we can see all the methods that we can do here. And what we're going to need to use is the add method. So that's the first thing we're going to need to implement. The add method takes either a body or a behavior and it adds it into the world. So let's implement that. So we're going to implement def add. So the first one we're going to implement is add, which takes a body. And this is going to be of type body. And this is going to be implemented as js.native. Now let's implement body. So we're going to do the same thing that we did before. Body extends js.object. We can switch over to the docs and go to body. And we can see under the body class what methods we have. So we have all of these different methods. And the only one we're going to need right now is the state. So we're going to have a var state, because this is mutable, we can change it around. And this is going to be of type body state. And this is also going to be implemented as js.native. Now let's implement body state. So in this way, we're kind of recursively creating all of these static types. So trait body state also extends js.object. And let's take a look at body state. So the state has a position, a velocity, and an acceleration, as well as angular position, velocity, and acceleration. All we're going to need right now, though, is the position. So I'm going to have a var position, and this is of type physics.vector. We'll take a look at that next. Of type vector, this is also js.native. Let's take a look at physics vector. Physics vector is a two-dimensional vector here, and to get elements from it, they have a method. Where did my vector go? Vector. They have a method get, and get takes an index and returns you a number. So I can go and create a trait vector, and this is also going to extend js.object. And the first method we're going to have is get. So I'm going to do get, which takes an index I of type int. If we go back to Chrome, we can see. So here we have this dot get, and this is going to return us a number, and we know that's just going to be a double. This is going to be implemented as js.native. And we also have def set, which takes an index of type double and a value of type double. And this is returning unit, because we're setting a value, and this is also going to be js.native. So now we have a vector and a body state and a body. Now, another thing we need the ability to do is to create a new body. And that happens in the physics object. So we can go back up to physics. Let's see, where is physics? Where is dot body? Yes, here. Physics.body. So there's a method physics.body which takes a name and a list of and the options for that body. So what we need to do is implement here in physics. We're going to do def body. It's going to take a shape type of type string, and it's also going to take a setup, which is the options, which is of type shape setup. This is going to give us in return a body of type js.native. And now we need to create our shape setup type. So we can create a trait shape setup, and this is going to extend js.object, and let's take a look at where are my shapes. Vector, behavior, here. So we have a bunch of different types of geometries, and we use these geometries when creating a physics.body. So this is what we're implementing. So if we have a geometry here, we have a bunch of different variables that we can set for our initial shape setup that are shared across all of the different types of shapes. So the ones we need to implement here are var x of type doubles. This is the original x position. This is js.native. The initial y, so we can actually just copy this. This is y. We need the initial velocity and in the x and y directions. This is vx and vy. And lastly, I don't need to copy, we have the treatment. So treatment tells PhysicsJS if it's a dynamic object that can move around or if it's a static object that other dynamic objects can bounce off of. And treatment is going to be of type string. So this is going to be either static or dynamic here. So, and this is also js.native. And that's all we need for shape setup. But we have different types of shape setup. So you might have a circle shape setup or a polygon shape setup. In this video, we're just going to implement a circle setup as an example. So we can do trait circle setup. And since shape setup is a trait, we can have this extend shape setup. And we don't have to do here extend JS object because shape setup already does that for us. And all we add in circle setup is the radius of type double, which is js.native. So now we have body of which takes a shape of type string and a setup of type shape setup. And when we have a circle setup, how do we create one? For that, we're going to create a companion object, circle setup. This is going to extend, this is not going to extend anything, but we're going to have a def apply, and this is going to take all of the parameters that we need for the shape setup and circle setup. So you're going to have x of type double, y of type double, vx of type double, vy of type double, treatment of type string, and radius of type double. Now, how do we do this? Well, if we go to the PhysicsJS documentation, and what are we looking for here? We are looking for circle setups creation. Let's see. How are they doing that? So if we go to geometry, circle geometry, what they're doing is they're just passing a JavaScript object created right there. And we can do that by using dynamic.literal. So if we go here, we can implement that and say this is going to return a circle setup. What we're going to do is we're going to use the dynamic object in Scala.js, and the dynamic object has a method literal, which lets us create a literal JavaScript object. And in this literal, we can just do x equals x, y equals y, and what this is doing, this it by itself would create an object where for the key x, it gives you the value x here. So it's creating an object with these key value pairs. Vx equals to Vx, Vy equals Vy, treatment equals treatment, and radius equals radius. So now we've created our circle setup. And with that, we're done with our basic static types. Now, one thing you'll notice is we haven't implemented all of the types for everything in PhysicsJS. And with Scala.js, a nice thing is that you can just build your static types as you go. So this is all we need for now, but as we need more types, we can just create them on the go. So now we have our static types for PhysicsJS. In the next video, we're going to be using these types to add a circle into our world and rendering it falling. So we'll see you next time.